So today we'll talk about a programming language called JavaScript. And JavaScript is, I'll go into a little discussion on the blackboard. JavaScript is a client-side programming language, unlike PHP, which was server-side. And I'll re-explain that again. But I wanted to go over some examples, and then this is, so my second example for tonight is this Super Bowl countdown thing. So since a lot of you guys are wearing Giants clothes since the Super Bowl was yesterday, and the Giants won, thought I'd go over an example, something like this. This is, again, I try to keep these examples simple, but this is basically a clock counting down. This is like the score of the game, and then when the clock runs out, it says Giants win, right? So in other words, to do something like that, you could put this in a web page. So obviously, while these numbers were changing, some program was running. And then when the number hit a certain value, something else changed. So we need to do something like that. So what I just want to do is go over how you could do programming on the client side. So just to give a little bit of a, I know you guys seem to like Facebook a lot. So if you go to Facebook, go to the normal login screen. If you look at the bottom of the screen, this thing across their footer, they have a button called Careers. Okay, and you click on their Careers thing, and this is like if you want to apply for a job there or an internship. And they actually just opened up a new office in New York City. They're mostly a California company. But then these are all the different areas that are hiring, and then if you click on software engineering or like the IT department, IT and security kind of overlap. Jobs. Okay, so then they have a list of like all the job openings, and then try to find one in New York City. For example, this one, software engineer pages, so maybe this has something to do with web pages. And then, a lot of companies have things like this, and then there's also websites for like what skills are being looked for. So, for example, this position says that you need a bachelor's degree or master's degree in computer science or related field. So what's a related field to computer science? Well, that would be, I guess, if you have an IT, I mean, some schools have computer science and IT together. Some schools like this have them separated. Maybe you have a minor in it, not a major, and you majored in something that's related to what the job is. So they're looking for you to have knowledge of programming languages like Perl, which we'll talk about shortly, and PHP, which we have talked about. We might talk about this language, Python, towards the end of the course, just to have covered another programming language. And then they'd also like you to know some web technologies like JavaScript, which is what we'll talk about tonight, and then these are other programming languages. Once you start to get good with some of these programming languages, it gets easy to learn other ones. They also have a lot of intern spots open this summer, if you're interested. But this is just Facebook. A lot of companies, I guess this is what it looks like when you work there. So it's not a suit and tie kind of place. Okay, so anyway, what I want to talk about, just the difference between what we talked about last class, which was one of the server-side programming languages, which was PHP. This is now, JavaScript is a client-side programming language. And just kind of a refresher, if we're connecting to the Facebook server, I keep using Facebook as an example because I know you guys go to Facebook a lot, so you might be more comfortable with it. And here's your PC or laptop. Maybe you have a laptop. And you're connecting through the internet. to Facebook, and then the messages, the web pages are coming back to you. When we did PHP last time, there's actually a program on the server, a PHP program. So when there's a web page that ends in .php as opposed to .html, what that means is if there's a web page on the server called x.php, and you go and you ask for that page, before the page is returned to you, that page runs through a program on the server. And this program, this is a computer program, you don't write it, the server has this on their end. This program will take any normal HTML tag and just let it pass right through. Eventually the page will come back to you. Eventually the page comes back to you. And anything that is in a non-PHP tag just comes back exactly as it is. But anything that is in a PHP block, if you remember, it starts like this, and it ends like this, I think. Anything that's in here, this program, which is running on the server, will remove this, so you'll never see it. But if there are instructions in here to put stuff in its place, it'll put that stuff in its place, and that you'll see. So I think one of the things we have to do on our project is we created a blog, so people can type in a comment and then you record their comment. Now one of the things you have to add to it is to put a timestamp. What time did they put their comment in? So on this side you can ask the system, what time is it? And the system will tell you all the information about the time, the day, the month, the year, hours, seconds, anything you want to know about the time, and you can customize it to read whatever you want from the system. This is the server. And then you can put that back in the web page if you wanted to and send it back to the person who's receiving it. So this is a program that runs on the server. What we could also do is have the actual program sent back to the person and have the program run on their machine. So there's an advantage to doing this. If there are a lot of people coming to our server is going to be very busy running all these programs. It might be nice to just send the program back to the person and have it run there. So like this Giants thing I did. So what, you guys are all quiet because you've been celebrating too much? You guys watch the game? No? Okay. So this is now a program that's running. Would you want it to be running, and I'll show you the program in a second, it's obviously something like if time equals something, then subtract 1, and then display the time again, and then subtract 1, and display the time again. Would you want that to be running on the server, or would you want that to be running on the client? Well, if we put this on the server, and then 1 million people did this, that's 1 million people running a very time-consuming program. If we pushed it out to their machine and had it run there, then all it is just one web page request, and then we're done with it, and it runs on their machine. So you might think every program should run on the client. If you're the person creating the server, you probably want everything to run on the client side. But there are some things you can't do on the client side. For example, with our blog, why couldn't the program for our blog be running on the client? Why would that have to be running on the server? What's that?
It would only update when they make a post, not when anyone else.
If they made a post, and the program that grabbed their post and recorded it to the web page only ran here, no one else would be able to see their blog, right? So they could blog to themselves, but nobody else would ever see their blog. We would have to go back to the server to record it for other people to see. So a blog, writing to a blog is something you'd have to do. You have to use server-side programming like PHP or that other language, Perl, which could run on the server. But there are things we'd like to just push out to the client. So it's kind of a judgment call, which one should be used. What's that? Okay, so it's kind of a judgment call which one to use, but like you saw in that ad for the Facebook, they would like you to know both of them. So obviously you're going to be creating web pages and you're going to decide, should I have the program run on the client or should I have it run on the server? Okay, so let's go over a pretty simple example. Oh, one thing. What if you are in New Jersey and you're logged into Facebook, which the server is in California, and you write to a blog and for some reason they want to timestamp it. What timestamp should we use? So right now it's 6:20 p.m. in New Jersey, which means it's 3:20 in California. So if it got timestamped as 6:20, then the timestamping, the code that said to the computer system what time is it, and then stamped it, probably ran in New Jersey, right? If the time said 3:20, it'd probably be in California, and then if you wanted to make sure that all times were local, maybe you could pick one time zone, timestamp everything in the one time zone, and then if the person is 3 hours later than you, you could just add 3 hours when you display the timestamp. But you could kind of see, you could get into trouble if you ask the computer system, what is the time? And the computer system of the user and the server in two different time zones. Depending on which way you decide to do this, client side or user side, you might get a different timestamp. So something to take into account when using timestamps. And the server and the client are not in the same time zone. Okay, so this is a really, probably the simplest example, hopefully the simplest example, of a client-side system data being displayed on a page. Is this right? 623, okay. So the source for this code, source for this web page, and these are very boring pages because I want the input file to be as small and easy for us to see and understand. Obviously we can put, nice colors around this later on. But here we basically have a web page. So the web page is standard HTML, and this file, oh, it's unfortunate, you can't see the whole file. This file name ends in .html, so we don't have to do that thing where you have to rename the file .php. Remember, the reason for changing the name to .php or other server-side programs like ASP and JSP is the server needs to know before it sends the page back, it needs to know it has work to do. That's why it had to have a different name. This file can have the name HTML because there's no work for the server to do. I'm asking for the page, and the server's just sending it back. It doesn't do any thinking at all. If the file ends in .html, it just sends it right back. So this is exactly how it appears on the server, and it's exactly what I received when it came back. So if the server's out in California and I'm in New Jersey, and I ask for this page, it ends in .html, it comes back exactly as it is. Once it arrives, if there's a program embedded in this page, that program will run. So here's the standard HTML header, the body, then I write a line that says writing client-side data to this page. Now here's the new thing, this block. You know the end of the body and then the end of the HTML page. This is the new thing. So we have a new tag, script, type equals, and we're basically saying this is a JavaScript. And it does something very simple. It takes this page, which is the actual page you see, that has the name document to it, and I'm calling a function called write, and I'm writing to the very document that you're looking at. I'm writing standard HTML. I'm saying here's a new paragraph, so put that in double quotes, plus date I'm asking the system that I'm on at the moment, what do you think today's date is? And it actually ends up giving us this format. So it gives us the day, the month, the day of the week, the month, the day, the time, and then the year. If you wanted to, if you didn't want all of this information, all you want to know is today, what's the day of the week. Maybe you want to have a web page that says today is Monday, and that's it. You could do that. And there's options on the date thing. You could say date, and then I think if you say M, it might give you the month, and Y might give you the year. And this stuff you don't have to memorize. You could just always look that up in Google. You could just Google JavaScript space date space day of the week, and it will tell you, say date with something in the middle, and that just lets you know that's what it will return. So if you just say date, it tells you all the information that the computer system knows is today's date. And then that's the end of our script. So this is a program that runs right when the page arrives to the client who wants to view the page. So the page arrives, this thing goes and gets the date, treats it like a new paragraph, and I'm just writing HTML straight to the page we're looking at, and that's what this came out to be. So if I refresh this page, it should update the page. And now it's 6:28. It was just 6:23 before, so now it's 6:28. Now if we let this sit here on the screen for the next 5 minutes, it's going to still say 6:28. It's not going to constantly keep updating. If we want to constantly keep updating, we have to make the program a little bit more interesting. So does this, does this seem, does it make sense what we're doing here? Like I say, this is just one simple example. But the reason I use this, so it's just one line. Here's the beginning of our JavaScript. Here's the end of our JavaScript. We could put in a program, which is a sequence of tasks to arrive at some kind of a goal. And then, one of the things it can do is write its results directly to the web page that we're looking at. Now, if we wanted to do things like figure out how many more days is it until, what's the next holiday? Valentine's Day? So we could ask the computer system what is today's date. And then we know Valentine's Day is February 14th, and then we could say today's date minus February 14th is how many days, and then say it's X number of days until Valentine's Day, or St. Patrick's Day, whatever holiday you want to track, if you want to know how many more days is it until something happens, or the semester ends, or the final exam. You could do that. So you're just putting in this block, a program, and then when the program's finally done, obviously you want to see the results. So somehow you're going to end up saying something like write it out to the document. Okay, so maybe an example that's a little bit more interesting is this one. Tried to get this to all fit on one page. So this is the countdown. Okay? And I'm just hoping that from some of these examples, you just get an idea of, oh, if I can do that, I can do a lot of things similar to it. So again, this is a web page. We have the HTML, the header section, if we wanted a header section. And now I have the body, I have a form, and I give the form a name, called it game status. The input of the box is text, I give it a size of 30, and then I have the score. I have a field called the score. So right away, what does this mean? This means that this box, so I actually did this as two separate forms. We could have done this as one form. And I'm putting right in this box, I have this form is called the game status, and what's inside this box I'm calling the variable the score. Then I have another box down here, which I call this form the counter, and I have seconds left is what appears inside the box. Okay, so those are forms. That has nothing to do with JavaScript yet. Right? Remember, every form has, the form has a name, and then fields inside the form all have their own name. Okay, so now I start the script. And what I'm doing is I need two variables. So remember we talked about programming originally, like if you had 5 variables and you want to know what's the biggest one, you had to look at each one, so you had to record where the data is. So I'm going to have milliseconds and seconds. I'm going to initialize the seconds to 10. That's why when I start this thing, it always starts at 10. I can make it start anywhere else, any number else I want. And then what I'm able to do, and this is just something, after you do this enough times, you get very comfortable with this. What we're looking at is the document. The document is the page we currently see. So JavaScript always calls the current page the document. Under document, you say dot, the counter, that's this form. So the counter, the field in it called seconds left. So in the counter, if I wanted to make this form bigger, I could have many fields. So in the counter, under seconds left, there are attributes about it, like what color is the foreground, what color is the background, what is its value. There's a whole bunch of attributes, and you could Google them to find those. The value starts at 10. And then I said the document, the game status form, which is this one, has a score field, and its value is Giants 21, Patriots 17. Okay, so I'm just saying what these would be initially. If I then just printed the page and stopped at this point, it would just say Giants 21, Patriots 17, and this would say 10, and it would be frozen there. But now I want things to happen while the page is running. I want a program to run while the page is running. So it looks like what we're going to have to do is, if this says 10.0 seconds, what we would like to do is every so often, we would like to, based on what the current value of the number is, we would like to change it to a new value. So if it's 9.6, we'd like to display that for a little while, and then change it to what? What comes after 9.6 if you're counting down? 9.5. So we'd have to have something that says, well, if it's currently 9.6, make it 9.5. And then if it's 9.5, make it 9.4, and so on. Now it gets a little bit tricky when the milliseconds hits 0. We don't want to make that -1. If the milliseconds hit 0, we want the milliseconds to go back up to 9 and then the seconds to drop by 1, right? So if it's like 4.0, what's the next number after that? It's 3.9, right? So the 4 should become a 3, and the 0 for milliseconds should then become a 9, right? We would need to do that. And we want to keep doing that forever and ever until the clock hits 0, and then we want to stop this. And then when the clock hits 0, we could do something else. So, since we're going to keep doing that same thing over and over, one way we could have done this, I could have wrote a line that says, if the current time, if the current seconds and milliseconds equals 9.6, then make it 9.5. And if the current time is 9.5, then make it 9.4. And if it's 9.4, then make it 9.3. I could have wrote out 100 lines that kept repeating that, right? But there's another way to do it. Since it's pretty much the same operation we just keep doing, we could just take whatever the current value is and run the operation again. An operation that subtracts 1 from it. And just keep doing that over and over. So I don't have to write it 100 times. I could just write it once and then just keep performing that operation over and over again. So I make this function called display. And the purpose of this function is to subtract 1 millisecond from the current time, and then redisplay its results. Because that's all we're really doing. We're taking 10.0 and we calculate the next number, which would be 9.9, and then we display it. And then we calculate 9.8, and then we display it. Right? We just keep doing that until it hits 0. So this function is basically saying milliseconds equals milliseconds minus 1. Right? So if it's currently, so if seconds, so the seconds and milliseconds. So if it's currently, if the values are currently 9.6, we would display that. Then what should we do? We should subtract 1 from here. Always we subtract 1 from here. Should we change this one? Should we change the 9? So we don't need to change the 9. So we would say something like, well, if this is now
0.
less than 0, if it became -1, that wouldn't make sense. So if it was less than 0, we would then reset this one to 9 and then subtract 1 from here. So for example, if it was 9.0, we would display 9.0, and then our next operation is to subtract 1 from here to make this a -1. And we don't want to say the time is 9 seconds and -1 millisecond. That doesn't make sense. So if it goes below 0, then we go like this. We reset this back to 9, and then subtract 1 from here, and then we get 8.9. So it goes from 9.0 to 8.9. So we have to somehow put that in our code, just to do that logic. So, and then when does it eventually stop? When it eventually hits the point where it is 0.0, and we go to subtract 1, what we always do is we subtract 1 from here first. So it looks like the new number is going to be 0 with a millisecond of -1, which doesn't make any sense. And if this goes below 0 and this one is at 0, we should just stop. So we want to somehow incorporate all that logic into the program. So what this JavaScript program is doing is it's saying, every time somebody calls this display function, if I say display the result, we call display, what happens? Whatever the milliseconds are, subtract 1 from it. If that knocked us below 0, make milliseconds go back up to 9 and subtract 1 from this number of seconds. As long as the number of seconds is something meaningful, like the number of seconds is 0, the game is still running, then we will display the new value. So now we write to the documents counter form, that's this one, this form, its field seconds left, which is this field, and then we say its value is equal to the seconds variable, this one, with a dot, and then the milliseconds variable. We put those two together, and we've now decided, so if this, for example, said 9.2, and then somebody called the display routine, we would be changing this to 9.1. Now the question is, we'd like to display that for a certain amount of time. So there's a set timeout function in JavaScript, where what we can do is, we can call this routine display, and then this number here is how many milliseconds you want it to display for. So for example, if you wanted something to display for 1 full second, you would put 1,000 here. That means 1,000 milliseconds, so that's a full second. So you might think, why don't we just put a 1 here, meaning I'd like it to stay for 1 second. But what if you wanted it to go much, much faster than 1 second? You don't have anything smaller than a 1, so they let you put in milliseconds here. So what I'm doing now is I'm calling the display method and letting that sit there for 1/10 of a second. And then when that's done, I call the display routine again. And then next time I call it, it's going to subtract 1/10 of a second off of the number and then display it for 1/10 of a second. And this will keep happening. When will this eventually end? This eventually ends, I'm saying here, if the number of seconds is 0 or greater, then just keep doing this, keep displaying it. But once it gets to the point where the number of seconds becomes negative, that would mean we went from 0, 0, when this became -1, this became a 9, and this seconds became a -1. So now the time is -1 seconds with 9/10 of a millisecond left, which doesn't make any sense. We wouldn't want to display that. That would look confusing. At that point, once seconds goes below 0, I then write to the document, game status, the score, I now say Giants win. That ends up being the score. So this right here doesn't do anything. This function from here to here doesn't do anything unless you say run that function. I haven't run the function, I've just defined the function. Here is where I actually run the function. I call display. So I'm calling the display function, I'm saying run this task. And it's only going to run it one time because I'm only asking to run it one time, unless the function itself calls itself again, and that's what it's doing here. It's calling itself after 1/10 of a second. So I call a function once, the function comes in and subtracts 1 millisecond from the current time, and as long as there's still some time left on the clock, it runs itself, it displays itself again 1 millisecond later. So, for example, if I made this a 10 instead of 100, what would happen? So this is the function I'm calling, and this is when I'm going to call it, how much time from now I'm going to call it. And this number is in milliseconds, meaning if this was 1,000, it would call it 1 second from now. If it's 100, then it's going to call it 1/10 of a second from now, which would be pretty fast. What if I made this 10 instead of 100? What would happen? This is how long from the most recent call to display, how long the next call to display would be. So it should make it run a lot faster. If I go like this, it should make it run 10 times faster. No, wait, I can't get it. So if I edit this file, if I make this 10, it should move 10 times faster. So that was 10 times faster, right? And then if I made it, this might be too slow. Let me, if I made it 1,000, I may have to stop this. It's too slow. But. So what I'm now saying is, okay. So now, every second, it's subtracting the milliseconds. So that's why this clock is, milliseconds are now becoming seconds. So this would end up taking 100 seconds for this thing to finish. So what I'm doing with this code is basically, I'm writing to the document which causes the new display to happen, and then I'm saying 1,000 milliseconds from now, which is 1 second from now, call this routine again. And then when it calls it again, it recalculates the seconds and the milliseconds, and then displays it. And that'll just keep happening until the time runs out. So that's still going. Okay? So the thing is, you can call a display routine. Calling a display routine is basically, you can make any updates to any part of your document. Remember, your entire web page is a document. So you can make any update to your document by calling the field name. So for example, in this document, the document is broken up into different pieces, forms, or whatever sections of your website you want. And you can just go to that section, a field within that section, and then say its value equals something, its color equals something. You could do anything you want to, just by being inside a JavaScript tag, and then deciding what part of the document you want to alter. Now while this is going on, while this counter is running, and then this thing eventually says Giants win, does the server even know what's going on? The server that sent this page. Is there any communication going back to the server? No, because this is basically what was received from the server. Once the server sends it out, it doesn't even know if the receiver ever received it. Maybe your web browser doesn't know about JavaScript. I don't know, has anyone gone to a web page recently and got an error message saying you don't have JavaScript? Your browser doesn't have JavaScript. You got it recently?
I don't know. I know I have it. I have gotten it before.
Okay, yeah, it's kind of, now it's 2012, it's kind of weird that a browser would not know JavaScript anymore. When it first came out, there were a lot of browsers that didn't have it. So you would get a page like this, it would see that there's a block in it called, you'd have this script tag, and it knows that it's going to run JavaScript, and if your browser never heard of it, that means your browser's looking at all this stuff saying, what is this crap? I don't know what to do with it. And that's the message you get, saying, I don't know what JavaScript is. But then it would give you a link to download a free copy of it. So that would be something that would be added to your browser so your browser can understand this stuff and then run this program. So hopefully by now everyone's got JavaScript. But I remember, that was probably maybe 5 or 6 years ago, I'd get that error a lot. Be at a library or someplace and the browser doesn't have JavaScript and the page that you're looking at is encoded in JavaScript. Okay. So then, just like, well, 2 other things we'll cover for today, and then we'll talk about things that we could do with JavaScript. Okay. So, this is now an interesting thing. Once you get a feel for what JavaScript can do, you know how so in that last example, I made a function called display, right? And display would recalculate how much time is left and then call display again, right? So whatever time it was, it would do a computation and then call display again. And that program was inside the web page that we're looking at. So now the thing is this, does the program, suppose the program was really, really long. Suppose it was doing something a lot more complicated than just counting down and then when it hits 0 it says Giants win. Suppose it did something very complicated. It was very, very big. You'd have to put this huge block into your web page so the receiver will get a copy, right? And suppose this program was a common thing, like, let's say, for example, you know, like web pages that have scrolling pictures on them? And maybe we could do this next class. You know, like if you go to the Monmouth site, so this picture in the middle, this is now JavaScript. This picture is here and a timer is running. And when the timer runs out, another picture shows up. And then when the timer runs out, another picture shows up, right? This is JavaScript, or something like JavaScript. This is client-side programming. This file came out to us, and then it's saying after a certain amount of time runs, here's another picture. If this was done on the server side, it would be pretty painful, because the server would have sent the page, then the server would be running a timer. when the timer disconnects, even though we didn't ask for a new page, it would have to ship us a new page. If this program was running on the server side, it would have to just keep sending us pages even though we're not interested in pages. And here it's just running on our side. So if you wanted to do something like this, you know, and it looked, you've seen the cases where the pictures slide from left to right. This looks like it's exploding from the middle, right? Yeah, so it's refreshing out of the middle. So imagine you had to write a program that does this, sets a timer, then has the picture change from one picture to another in this manner. This big program would have to be written into your page, right? But that's a pretty common program. Maybe a lot of web pages want to do this. Would we want to rewrite this program into every page in the world where it exists? Or wouldn't it be nice if the program was written in one place and then we could all just refer to it? So in this case, the code for this one, code for this page, here's the HTML file that is displaying this page. But the important thing, I know it's almost like this example is almost too simple, you might be missing the point. But the point that I'm trying to make is, here's my HTML, the header, the beginning and ending of the header, here's the body, and the whole body is JavaScript. I have my JavaScript, and where does it end? It ends over here. Okay? And all I'm doing is saying the source for the thing you're seeing is somewhere else. There's a file, not in this page, somewhere else, called external program.js. And files that end in .js, that stands for JavaScript. So all I'm saying is what you're seeing right here is in a different file. It's not in this file, it's somewhere else. So this line that says this text is from the local file, that's this line of code here. But this text, which says this is from an external file, where is this coming from?
The external file, external
where's
program.
the header coming from? Oh, the header is also from an external JavaScript file. So what I'm saying is, I'm using this as a source, meaning somewhere else there is a file called external program.javascript. And that is, so I hope I didn't make this so simple that you're missing the point, but I want you to follow what this is. There's two lines to this. And all I'm saying is write to the document, right in the header section. Heading is from an external JavaScript file. And then in normal paragraph print, this is from an external JavaScript file. So now the page we're looking at looks like this. So what I did was, what we did here was, we have a JavaScript program, so you might think it would be some really long program that resides right here, but all I did was refer to another file somewhere else. And then whatever in that file is what we're looking at. Now this line, I could also add my own stuff from this file. But this would be useful if, let's say there was some program that we wanted on the top of every one of our web pages. We'd rather write the program once, save it somewhere, and then have 50 web pages refer to it, so it keeps doing the same exact thing. Now, just getting back to that idea of the JavaScript file, the pictures that keep, like on the Monmouth web page, where it explodes into another picture, that might be a very long program. And maybe somebody else already wrote it. Maybe Google has already written it and has it on one of their servers. So we don't have to rewrite it. All we have to do is find it. And then we'll say source equals http:// Google.blah blah blah, wherever they put their JavaScript file, and then we just use it. And all that file might need is 4 or 5 pictures. We give it 4 or 5 pictures and then call their program, and we could shuffle through pictures, and we don't have to go and write that whole program. So commonly used JavaScript actions are already out on the internet, and someone else has it in their JavaScript file, and all we have to do is use it. And they give this stuff out for free. It's advertising, so we'd be using their program, and then they could probably even put an ad on it if they wanted to, or just let it be known that it's their program. One downside to using somebody else's program is if they ever take their program down and your web page is dependent on it, your pictures won't show up. So if you were using somebody else's picture scrolling JavaScript file and just gave it as input 3 or 4 pictures, if their website went down, your pictures don't scroll. So sometimes it's good to copy their code, go get their code and save it on your machine. That way you don't have to worry about them going away. Okay, so any questions about, just, like I said, this is an introductory Java talk. So let me ask a question just on the idea of server-side and client-side programming. Have you ever logged into a website where you log into a website, you stay on it, and then you leave. You come back the next day, and as soon as you type in your login, it immediately knows your password. You're like, how does it know my password? You ever done that? You type in your username, and all of a sudden, your password shows up. You know, it's like the black ball, but they know your password, right? If you just had it, now that you kind of know server-side and client-side programming, how do you think that's being done? Did it go out to the server to get, did it kind of know you finished typing your login and it went out to the server looking for your password? What do you think? It's on the
client side.
Okay, if it's on the client side, where did it, had it? Yeah, it would save it in some file, right, that your browser has access to, maybe some file called passwords or something like that, but something related to the browser that connects, oh, when this person goes to this website and types in this user ID, I know this is the corresponding password, and they'll just display it for you. And that's not going out to the server to bring that back, that's something on your local machine. And have you ever logged into, like, you know, some password protected account, and as you hit log in, you'll be asked a question like, do you want the browser to remember this password, or are you on a public machine and you don't want it being remembered? You could answer yes or no. That's what it's doing. It's saying, do you want us to save your password? So, you know, if it's a home computer and you're the only person who ever uses it, it might be nice that the browser remembers your password. But if it's around at a library, you don't want the library to remember your password. And that's what you'd be answering yes or no. Okay, so that would end up being another example of client-side programming. And they call those cookies. Maybe next class we'll make a cookie. So we can create a form, and then somebody logs in, and then you shut the browser down, and then bring the browser back up, and it remembers what you typed in last time you were there. And that will be done in JavaScript too.